All right, good afternoon here. That's what it's afternoon. The kids are at grandma's and it is time to do some geometry. I hope that this really helps you guys and that you ask any questions you have afterwards because that is how we learn. We're going to do triangle congruence and triangle congruence proofs part 1. Learn all the theorems. So let's get started. Which two triangles are congruent by the SAS theorem? Complete the congruent statement. So SAS stands for side, angle, side. And you may be aware that there are 3 angles and 3 sides in every triangle, right? Every triangle has 3 sides and it also has 3 angles. And if 2 triangles are congruent to each other, that means each side has a corresponding congruent side to it, and each angle as well. So 6 different things. But we don't need to know all 6. There are some triangle congruence theorems, and what those are is they say that, so for example, one of my favorites is side, side, side. And that would be that if 3 corresponding sides in triangle, let's just say triangle ABC, are congruent to sides in another triangle, let's call it DEF, then triangle ABC is congruent to triangle DEF. We don't need to know about their angles. In fact, if we know all 3 sides, then now we know the angles are congruent as well. That is the strength of this triangle congruence theorem. Side, angle, side, congruence theorem. Side, angle, or side, 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 congruence theorem. So, what are the other theorems? They all have 3, except for one has 3, but we don't call it that way. So another one is side, angle, side. Hopefully you're writing all these down. So you got side, 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 angle, side. Another one would be angle, side, angle. Another one would be, what's another one? Angle, angle, side. Okay, write this down. Angle, angle, angle. But now draw a circle around it and cross it out. Angle, angle, angle does not work. Does not work. No. All right, have it 1, 2, 3, 4. Side 8. There is one more. There's one more. You might. I'm not even gonna write it this way because I've done it so many times. Maybe. Okay. I know what you're thinking. What about angle, side, side, right? Well, it doesn't work. Okay, I didn't write it that way. Side, side, angle, because this is a YouTube video for kids, okay? But angle, side, side does not work, okay? It does not work. But there is actually one exception, and it is in right triangles. So in right triangles, there is an angle side side that works in right triangles, but we don't call it angle side side. Because it's a right triangle, we can call this the hypotenuse. And if we know one of the legs are congruent, then we know the right triangles are congruent. So that last theorem is called IXL, and that stands for hypotenuse leg. All right, so that's the theorems. Now we're going to look at how do you actually use them. So let's see, side, angle, side. That means the angle is in between the 2 sides. We call the angle because it's in between an included angle. And I just had what I feel is sort of a revelation about how I can show you this. So it's a little bit more in depth, but I'm going to show you the first way that I do this. So there's one hash mark here, so we're going to call that S1. There's 3 hash marks here, so we'll call that S3. S3. This is a S2, an S2, and S3. Okay, so you can see if the 2 S2s are congruent, that's why they have 2 hash marks, because they're the same. And the 2 S3s are congruent. That's why they have 3 hash marks. I don't know why they put a 1, because we don't usually put a hash mark if there's not another side that's the same. But maybe just because they're trying to trick you. So that triangle is not congruent to the other 2 because it's the only one with the S1. And you can see the S2s, you can see the S3s, and then in between the S2 and the S3 is an angle. Angle E here and angle J here. So my idea, because some people don't see that this is side, angle, side. Sometimes people go, wait, isn't it like, can't I go around this way? Or I don't get it. So my thought was, if we can write the angles in the order that they correspond, E, D, C, and in this one, if you can figure out, so J, I, H, and then side ED. So these are angles. And I'm not doing this one for any other, I'm not going to make this chart for any other triangle problem, but this one, it's just if you really are getting stuck, you can go and build this chart. So ED, and in between those angles is side ED, in between D and C is side DC, and then there is side EC after angle C, right? After angle C, there's side EC. Okay, between J and I is side JI, between I and H is side IH, and after H is side I. So we got IJI, we got HHJ. Okay, so what do we know? We know S3 is DE, S3, and we know E is an angle, and then we know EC is another side. Okay, and then here we know J is the angle, and we know JI is S3, and then we know HJ is S2. Okay, so I'm making this chart to show you why this is not angle side side. Some people think it's angle side side because there are 2 sides and an angle. But you can't call it angle side side because you're skipping all these things. You can't, when you're doing the congruent statement, you can't skip over angles and sides without being wrong. So if we go this way, you know, it's like Pac-Man, you go off the screen and you go to the other side. It's side, angle, side. Yes, so you can't go this way. You have to go in the direction of not skipping anything. All right, so hopefully that helps. But if it doesn't, just ask your questions. And so we also, when we write congruent statements, we have to write the corresponding angles in order. So EDC and JIH. EDC JIH. So angle E and J correspond, D and I, and also C and H. So you have to write it in the right order. Okay, I spent a lot of time on that one, so that maybe I don't have to spend a lot of time on some other ones, but actually this one is a doozy. Okay, because this is our first proof of, well, triangle congruence proof. Okay, and so whenever you do a geometry proof, there are some different ways to do it, but they always start with the given. And the given can be written, or it can be marked in a picture. And the reason why I made this little chart is because on one side, we're going to put statements, congruent statements. We're going to, it doesn't have to be a congruent statement in a proof. It could just be other type of statement, you know, an equation or something else that you want to say about the figure in order to prove something you want to prove. But you make all your statements on the left, and you put all your reasons for that statement on the right. This is called a two-column proof. All right. So before I start my proof, I always mark up my picture. So I'm going to put a S1 there and here, and a S2 here and here. Okay, and then we need one more congruent item. Okay, so what we want to do is prove that these two triangles are congruent. And so we're going to use one of our congruence theorems that we just talked about. And so, yeah, what is that one more statement? What is that one more item? Well, you have to know, you know, your theorems and your postulates that you learned previously. And one of those things is about vertical angles. We have vertical angles. So angles in X across from each other are always congruent. They're vertical angles. And so those angles would be TXW and VXU. Okay, so we can label that an A. And hopefully you can see like it's clearly side angle side. So the two pieces of given information, and it doesn't really matter if you put S1 is the S1 or the S2 first. I'm even just going to put it as one long statement. So TX is congruent to XU. All right, and also, okay. No, I'm going to do it like this, and you don't have to, but I just think it really proves the point. So that's my side, and then I know my angle, so I'm going to write that next. TXW is congruent to TXW. Oh, actually, it's UXV. And oh my goodness, I forgot to give my first reason. My first reason was given because that was marked in the picture before I got here. But the second was not. I know that those are vertical angles. So my reason is the vertical angle theorem. And I love to write theorem with an abbreviation like my college professor did. TH and a little M with the underline. I just love that. All right, my third statement is going to be the second side pair. WX is congruent to VX. That was also given. And now I have a side statement, an angle statement, and a side statement. So I can say my triangle congruence statement that they asked me about. UVX triangle. Triangle UVX is congruent to triangle TXW. WX. And the reason is the side, angle, side, triangle, congruence. And this one is, depending on your text, it could be a theorem or postulate. But when I was growing up, it was a postulate. So that's the side, angle, side, congruence, postulate. All right, good stuff. Now about the other two. So let's look at the other two. So our S1, A2, A1. Okay. So I just mark up my congruence markings with the A for angle, S for side. And now I'm not going to make that chart. You know, I can make it in class if you need me to, but as I look around the triangle, this is side, angle, angle, which is the same as angle, angle, side. This is also an angle, angle, side. And this is, oh no, they're all angle, angle, side. But which two triangles are congruent? S1, A2, A1, S2, A2, A1, S2, A2, A1. Okay, so that's out. So it's got to be these two because these have a S2, A2, A1. That one has a S1. So triangle congruent statement coming up. Let's start here on side S2. We're going to go from top to bottom, GIH. GIH is congruent to triangle. So starting on S2 from the top to bottom, this one's upside down, so it's going to be BDC. All right, that was easy. That was fast. Finally a fast one. But now, here we go. Complete the proof. All right, and I want to just note that in IXL, completing the proofs is just filling in the blanks. But I am not doing that because I want you to actually try, just when you're doing these on IXL, forget that it's drop-down menus and just try it all by yourself first, because that is really going to make you a strong prover. And this is the most difficult concept in geometry. Give myself more room. If you don't want to do that, then you just might struggle with proofs, and that's not going to be fun, because depending on your geometry teacher, you could have more proofs or less proofs. If I'm your teacher, you're going to have a lot of proofs. Okay, so as for statements, R for reasons. We know our first reason is always the word given. Whatever is marked in the picture or told to us. Nothing is told to us, but it is marked in the picture that we have two congruent angles, two congruent right angles. So we might be using HL, but maybe something else as well. And then I wonder if you remember that these mean that those lines are parallel. Okay, so I'm just gonna write my given information. Angle Y is congruent to angle W. And my second piece of congruent information is segment XY is parallel to segment WV. It's given as well. Okay. Oh, I just realized I can tell you about my favorite congruent statement. I had told you about my favorite triangle congruent statement, but this is my favorite congruent statement. The reflexive property. All right, I hope you like the reflexive property, because once you know it, it just makes things easier. It's the shared side is congruent to itself. You might say, well, of course it is. Why do I have to say that? But we're making an argument, all right? So, middle schoolers, high schoolers, you love to argue, and we just need to go point by point so we make sense. So we need to say that XV is congruent to XV. And we can use that inside of a triangle congruence proof. That is the reflexive property. And there are also reflexive angles, shared angles, but we see it a lot with sides. Okay, so I'm going to mark that as a S1. So now I have an angle and I have a side. And because I have parallel lines, I can think of XV as, I'm going to extend it here. And I'm wondering if you remember parallel lines cut by a transversal. So if you think about this is the interior of two parallel lines cut by a transversal XV, well then that makes this angle and this angle alternate angles in the interior. And so they are congruent. Angle YXV, angle YXV is congruent to angle WVX. And the reason is the alternate A, interior I angle theorem, alternate interior angle theorem. It says if two lines are parallel, cut by transversal, then the alternate interior angles are congruent. There's also the corresponding angle theorem, the alternate exterior angle theorem. And if you need supplementary angles, the same side interior and the same side exterior. Okay, lots of good stuff. And guess what? Now we got everything we need. We got, I'm going to make 2 hash marks and call this A2. So let's just change the color here. So what do we got? We got an angle, angle, side. Angle, angle, side. I can't go side and then skip this angle and skip it. No, this is not. No. Okay. So we have our congruence. We can say triangle WVX is congruent to triangle Y. So I said WV, I went to my A2, so I got to go to my A2. YXV. YXV. And the reason? Angle, angle, side. Angle, angle, side, triangle, congruence. I know you're like, postulator theorem, Mr. Field? I know that's what you're saying. Theorem. We prove angle, angle, side based on angle, side, angle. Or based on side, angle, side or something. But, yep. All right, last one. Can you conclude that these two triangles are congruent? Well, we have our A1. We have our A2. And what's Mr. Field's favorite? Reflexive property. Okay, angle, side, angle. So I'm not going to prove this one because it's already a long video, but yes, they are congruent by angle, side, angle, triangle. Oh, triangle congruence theorem. And don't forget about the reflexive property. All right, yeah, so the reflexive property and the vertical angle theorem and the alternate interior angle theorem and sometimes a corresponding angle theorem, they show up, they find their way into these triangle congruence proofs, as do some other things at times. So ask all your questions and I will see you in class.